Addition and subtraction of complex numbers is a fairly straightforward process, much like adding and subtracting polynomials. So let's look at some examples and see how close these two processes are. If I start with the first example of one complex number, 6 plus 2i, plus another complex number, negative 13 plus 9i. All I really need to do is act like I is a variable and then combine like terms. So I put the real portion with the real portion and get negative 7. Then put the imaginary portion with the imaginary portion and get 11i. And as soon as I confirm that these portions of my answer are in the right order, real then imaginary, I have my complete answer. If I look at a second example, something that involves subtraction, I could have negative 3i plus 2 minus 7 minus 8i. And I'm going to treat this exactly like I would any other polynomial subtraction problem. For me, that's distributing a negative 1. For some other people, it's changing all the signs after the negative sign. However you deal with polynomial subtraction, you can use that here. So that makes this negative 3i plus 2, and when I distribute, I get plus negative 7 plus 8i. And again, I just combine like terms and treat I like a variable. So the negative 3i and the 8i is going to go together to give me 5i. The real portions, the positive 2, the negative 7, it's going to give me minus 5. And I have to remember that style matters. The order that I write these answers in makes a difference. So I put the real portion first with the negative 5, plus 5i is the imaginary portion. And that is my final answer for the complex number subtraction. The only thing that can happen to make these more complicated is if I have something like example 3, where I have 4 plus the square root of negative 9 plus negative 3 minus 2 square root of negative 144. In this case, I have to do a little bit of simplifying before I can do the adding. I just have to realize that the square root of negative 9 is going to become 3i. The negative underneath becomes I, and the square root of 9 is 3. Here I have to realize that the negative 144 is going to give me a 12i when I take its square root. So if I rewrite my problem with these quantities, I get 4 plus 3i plus negative 3, and then I have negative 2 times 12i, which is minus 24i. Now the problem looks just like what we started with, where all I need to do is combine real with real in order to get a positive 1, and combine imaginary with imaginary. 3i and negative 24i gives you negative 21i. And since my problem is written with the real portion first and the imaginary portion second, I'm finished with this problem.